Hey, welcome back to math class. Let's do lesson 2. So in the last lesson, if we learned that if we were given the focus and the directrix of a parabola, that we could do some wacky algebra with the distance formula and we could find the equation of the parabola. And we did that when we knew what the number p was, right? Well, if we don't know what the number p is, and we do the same thing and we just leave it p, then what we get is like the general formula. So let's do that. So let's assume that our focus is 0p and our directrix is y equals negative p, which means the point, if we pick any point xy, the point on our directrix is x negative p. So let's find the distances, and see what happens. So let's do the distance between F and P. And that is the square root of the difference of the x values. So x minus 0 is just x, and then we square that, plus the difference of the y values squared. So same direction, we did x minus 0, so we'll do y minus p. And this is going to be equal to the distance between D and P, which is the square root of x minus x is 0, so we don't have to do anything there, and y minus negative p is y plus p, and then we square that. And then we got square roots on both sides, so if we were to square both sides, the result would be that the inside of this radical equals the inside of that radical. So x squared plus the quantity y minus p squared equals the quantity y plus p squared. Now we remember that when you square a binomial, you have to do you might know it as FOIL, or you might remember the pattern for a square binomial becoming a perfect square trinomial. Either way, we realize that we get some terms in the middle. It doesn't just turn into y squared minus p squared. All right, so let's simplify a little bit here. X squared can't do much, but y minus p squared is going to be y squared minus 2py plus p squared. And then y plus p, quantity squared, is going to be y squared plus 2py plus p squared. And then we can subtract some stuff. If we subtract y squared from both sides, they basically just kill each other. If we subtract p squared from both sides of the equal sign, they basically just kill each other. And then if we were to add 2py to both sides, these ones would kill each other, but these ones are not opposites, so they would add up together. So on the left side of our equation, the only thing we have left is x squared. And on the right side of our equation, we got 2py plus 2py, that's 4py. And then if we want to think about this as the equation of a parabola, we'll divide both sides by 4p to get y by itself. And the result we're going to get when 4p divided by 4p is 1 is we're going to get y equals 1 over 4p, so 1 over 4p x squared. Now, you might be asking yourself, why in the world would I ever do what we just did? And the answer to that question really will show you kind of the power of algebra and why algebra is cool. So let's remember a problem we did in the last lesson. Remember this guy, and we had to use the distance formula, and then you did the practice and you did a bunch of problems where you had to do the distance formula again. But now we just did some algebra with one extra variable, p, and we found out that y equals 1 over 4px squared. So now, anytime we have a problem like this, we don't have to do all that distance formula work. We just have to figure out what p is. And if you look at the focus is 0p. So all I got to do, I know p is 2. So the equation of this parabola is 1 over 4 times 2x squared, which is 1/8 x squared, which is a lot easier than all that distance formula junk we did to get the exact same answer on the last lesson. So, hey algebra, boom, that's power. So we get this little result here. Standard equation of a parabola with a vertex at the origin and a vertical axis of symmetry, meaning it opens either up or down. Y equals 1 over 4p x squared, where the focus is 0p and the directrix is y equals negative p. This is the case when p is positive, right? P greater than 0. When p is positive, that means that this number in front of x squared is positive. We used to call that number a, which we still do. This is y equals ax squared. It's just that a is 1 over 4p. So that's how we can kind of tie our focus and directrix into the other ways that we understand parabolas. So if p is positive, then 1 over 4p would be positive and our parabola opens up. If p was negative, then 1 over 4p would be negative and our parabola would open down, and we would get a case that looks like this. So when p is negative, the focus is still 0p, but now since p is negative, our focus is down, which means our parabola opens down. Directrix is still y equals negative p, but remember that since p is negative, this is going to be y equals a positive number. And then remember that you can have parabolas that open up to the left and to the right also. So if you have a horizontal axis of symmetry and p is positive, so remember in the x direction, to the right is positive, to the left is negative. So if p is positive, then your parabola is going to open to the right. And if p is negative, then your parabola is going to open to the left. And if you notice, the only thing that changes when you have parabolas going right or left is instead of y equals 1 over 4p x squared, it's x equals 1 over 4p y squared. Your focus, instead of going up or down to get to your focus, you're going to go right or left, which means that your focus is now going to be p comma 0. And your directrix is a vertical line now, so it's x equals negative p, not y. Okay, let's take a look at an example. We want to identify the focus, directrix, and axis of symmetry of this equation, and then graph that dude. Well, let's look back at our little notes that we took, and which one is this going to match up with? Well, the y is squared, so let's see, on the top the x is squared, on the bottom the y is squared, so it's going to be one of these that opens to the right or left, and I want to get it to look like this. I want it to look like x equals something y squared. So I am going to divide both sides of this equation by -4, and that gives me the equation x equals -1/4 y squared. So we can see now that this matches up with x equals something. My p is going to be negative because I have a negative a, so that is this guy right here. So we can ignore the other stuff, and we can move some stuff up here. That was awkward. PowerPoint, you have failed me. Anywho, let's see if we can identify the focus, directrix, and axis of symmetry of this equation right here. Okie dokie. The equation is in the format x equals 1 over 4p times y squared. So this guy right here is our 1 over 4p. So all I got to do is say 1 over 4p has to equal this guy, negative 1 over 4. So I need to get p by itself. And if you're anywhere near my level of maturity, you're probably cracking up every time I talk about p, especially when I said my p is negative. That was kind of funny for me. I'm going to multiply both sides by p. So on the left side, my p's cancel out. And then I get 1/4 on the left side. And on the right side, negative 1/4 p. And now I could get p by itself by multiplying both sides by the reciprocal of negative 1/4. And the reciprocal of negative 1/4 is negative 4 over 1, also known as negative 4. So on the left side, these 4's cancel out. 1 over 1, 4 over 4, they're both 1, but we got a negative, so this is negative 1. And on this side, the negative times the negative is positive, and then we get a 1 there, so this is just 1p, which is p. So p is negative 1. So that tells me that my focus, let's see, p0, so negative 1, 0. On the graph, that's negative 1 up 0. So that is me focus. The directrix is x equals negative p. So negative 1 is positive 1. So x equals 1 is a vertical line that I draw so straight and nice right there. Our axis of symmetry goes through the focus, so it is the x-axis. So it's the x-axis, also known as the line y equals 0. And then to graph the equation, I know that the vertex is halfway between the focus and the directrix, so the vertex is at 0, 0. And then I can just plug in some points. I can make myself a nice little xy chart. Now since the x is just x and the y is y squared, it's going to be easier to pick our y values and then find out what x is going to be, especially because it says x equals. X equals means if I pick a y value, I'm just going to do some stuff over here and find out what x equals. I already know when it's 0, 0 times anything is 0. So we got the point 0, 0, that's our vertex. What about when y is 1? If y is 1, then we do x equals negative 1/4 times 1 squared, which is just negative 1/4. So that gives us the point negative 1/4, 1. So negative 1/4 and then up 1, so that's right around here. And then this is our axis of symmetry, so that means we have a mirror image down here at negative 1/4, negative 1. What about when y is 2? That means we would do negative 1/4 times 2 squared. That's negative 1/4 times 4, which is negative 1. So we get the point negative 1, 2. So negative 1 on the x, up 2 on the y. And then we have a mirror image down here because of our axis of symmetry. And I just wanted to switch up my colors real quick so that the focus was green and then all the points on the parabola were the same color. And then I got a 4 on the bottom here. I'm going to pick y equals 4 for my last set of points. So x is going to be negative 1/4 times 4 squared, negative 1/4 times 16, which is negative 4. So I get the point negative 4, 4, negative 4 on the x, up 4 on the y, and the axis of symmetry gives me a mirror image across at negative 4, negative 4. And then to finish off my graph, I just got to draw a nice little curve that goes through these points. La doo la da dee. Alright, so that's pretty much what my graph's going to look like. Try not to forget how awesome you are. Hope you have a great day. Go do practice number 2, and I'll see you on the flip flop.